So let's look at a little bit of an introduction to phase changes. And I'm going to come back to phase changes periodically, and we'll dive a lot deeper into kind of the math and what a phase change really is. But let's just do a quick introduction. And the I want you to imagine an ice cube. How do we change that solid water into liquid water? Well, we heat it up. And once that liquid water, how do we change that into a gas? How do we change that into water vapor? Well, we continue to heat it up. What are you doing when you heat a system? You're, yeah, you're increasing its temperature. But what is that? You're adding energy to it. And so that's the key point behind a phase change is that adding energy to a system can aid in overcoming intermolecular forces. So if we look at this little diagram down here, we can see we got a solid here on the left, and that's at a very low kinetic energy, very low temperature. If we give those molecules more kinetic energy in the form of heat or increase their temperature, then that solid will melt into a liquid. Notice here the molecules are still kind of associated with each other. They're just rolling over one another. But if we increase the temperature, again, we're going to vaporize that liquid into a gas. And so increasing the temperature by effectively giving the molecules more kinetic energy allows allows those intermolecular forces to be overcome. So there's stronger intermolecular forces as a solid, and then as you get to the gas, the intermolecular forces have been overcome. And the amount of intermolecular forces is directly related to some physical properties like melting point and boiling point for a compound. In fact, the stronger the intermolecular forces, the higher the melting point and boiling point of the substance. And let's compare propane, which has the formula C3H8, and compare that to water. Now, propane, you probably experienced this if you like to barbecue. Propane is the gas that is combusted to heat up your grill. Now, you might have noticed me say propane is a gas. And in fact, at room temperature, yeah, propane is a gas. Its melting point is very low. So solid propane, freezes at negative 188 degrees Celsius and it boils at negative 42 degrees Celsius. So at room temperature, it's a gas. Water, on the other hand, has a melting point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. So a very wide difference in physical properties here. And I want to point out that water is a much smaller molecule than propane. Propane has a little bit of a higher molar mass. If you want to do a quick calculation, you can see that. Same with water if you do a calculation. Yet there are much stronger intermolecular forces in water. We'll talk about those in a little bit. And there's much weaker intermolecular forces in propane. And so before we go into the specific intermolecular forces, I want to highlight the commonality between them. All of these intermolecular forces are interactions between something that is positive and something that is negative. We've all heard the term opposites attract. And really, this intermolecular force thing is about opposite charges attracting. Now, they might not be a formal plus charge, +1 and a -1. They might be partial charges. They're not completely a full charge. And we use this little delta symbol. So either partial positive or partially negative. And so in the coming videos, we're going to kind of dive into these specific intermolecular forces.